we're in the section of optimization, and so what we want to do is we want to optimize efficiency, optimize, we want to maximize things like profit, minimize things like cost. We want to be optimistic. Optimization in calculus centers around this idea that often the best ways of functioning or best choices to make in context of problem are choosing the local maximum and local minimum. Now, today we're going to do number 6 and 7. So we're going to leave the rectangular problems behind, you know, where we're maximizing area and stuff like that. Those all kind of just, they're all kind of the same. This one's a little bit different. It says, find the equation for a line tangent to the curve f of x equals 2x minus 6x squared minus x to the third. So what would you do? Okay. Coordinate plane. Draw that. I don't know exactly what it looks like, but I'm guessing it looks something like that. What do you think? I mean, if it's negative, it's going to start up and go down. I do know it goes through 0, 0 because that's the x and y intercept. What I would like, I need a volunteer. Here, Luke. Okay, I need somebody to put a point on this graph where the function would have the largest slope. Yeah, largest slope. Largest slope. Ooh, Z-Man. You think you know? Okay, all right. Thank you, Megan. Give her a round of applause. She did great. Kind of like Vanna White. I mean, you're just up here as they were directing you. Great job, right? Wheel of Fortune. Okay, Vanna White. Yep, Wheel of Fortune. Okay, so you did know that. All right. So, you're right. That would be the approximate placement of the spot where the slope is the largest. It's the greatest. Now, you need to understand this, okay? What point on the curve is that? The inflection point. When does the inflection point happen? Second derivative is equal to 0. So, as we do this problem, we have f of x is equal to 2x minus 6x squared minus x to the third. And that is our position function. That tells us where we're at a given time. However, f prime of x, what is f prime? That is our slope function. And it's saying largest slope. So largest, we want to maximize, and slope is the derivative. And in order to maximize a derivative, what we do is we take a second derivative, okay? So derivative of a derivative. So second derivative is, you guys said also, that's where the inflection point happens. Negative 12 minus 6x, set that equal to 0, x is equal to 2. So the goal of this problem is to write an equation for the line. If I want to write an equation, or I'm sorry, negative 2. So if we want to write an equation for line, we need slope and we need a point on our line. Well, all I know right now is the point on the line. I have negative 2. That's the x value. What would the y value be for the point? Plug it into the original. Very good. And we get negative 20. Trust Marcus today. What about the slope? Plug it into the derivative. The derivative will tell us the slope at that time. So negative 2 plugged into the derivative, I get 2 plus 24 minus 12, 14. We will write the equation for the line, y minus y sub 1, so plus 20, equals m times x minus x sub 1 plus 2. You could leave that on the AP Calculus exam in the free response section. They would accept that as an answer. I'm going to ask you to put it in slope-intercept form. Y equals 14x plus 8. Done and done. Right. What? Oh, all right. So when that was the problem that says the largest slope, it didn't say write an equation for line tangent at a given point. We had to find that point by determining where the largest slope happened. Okay, sounds good. Let's try the next one. This is a big boy problem. Okay. Now we want to find the equation for a line through the point 4, 2, and it cuts off a triangle from the first quadrant with the smallest area. You tell me. This will be our last problem of the day, and we'll do the number 8 tomorrow. What do I do? Draw my box. Okay, so we're going to take Katie and Marcus's thoughts, and we're going to draw this coordinate plane here, and we will plot the point 4, 2. Now, the line travels through 4, 2, does it not? And it cuts off a triangle. Great. What now? Okay. O goes to area of the triangle is equal to 1/2 times the base times the height. And Bo recognizes that the base is equal to the x-intercept and that the height is equal to the y-intercept. So I don't confuse x and y. I'm going to choose other variables. I'm going to have that have a coordinate of q, 0, and I'll have this one have a coordinate of 0, r. What do you think? So if I want to write an equation for a line, I need two things. I need slope, and I need a point on the line. Do I have the point on the line? So the only thing that's working or changing this problem now is going to be the slope. So the slope is going to determine what kind of triangle I get. So what I need to do is this. I need to come up with a function of slope. So what I'm going to do is I'm going to use these points 4, 2, and Q and R in order to come up with an equation for M. And watch how I do this. We're going to do two lines. We're going to do one for Q. q0 and 4, 2. And y minus y1 equals m times x minus x1. So in both these situations, it passes through 4, 2. So the equation will be y minus what? 2 equals m times x minus what? 4. Now, I also know that it passes through the point 0 or q0. So I could put q in for what? X, and 0 in for, so I get a negative 2. I put 0 in for y, equals m times q minus 4. Again, what we want is we want an equation with m, because slope is what's changing here. So I have an m in my equation. I want to solve for not m, I want to solve in terms of m, but my equation is going to be 1/2. Everybody agree that if I have 1/2 qr, that's going to give me the, solve for q. So we want q to equal something. So what I can do here is divide both sides by m. So negative 2 over m is equal to q minus 4. And then, so 4 minus 2 over m is equal to q. Very good. Do the same thing for r. So we have 0r, and we have 4, 2. You know that your line is y minus y1, or 2, equals m times x minus 4. What do I put in for y? R, so I have r minus 2 is equal to m times, what do I put in for x? So it's times negative 4. If I solve for r, I get r equals 2 minus 4m. What do you think of that? Okay. So what we're going to do now is say that the area is equal to 1/2 times q, or 4 minus 2 over m, times 4 minus 2m. Oh, right here. I wrote it right over there. Sorry. There we go. Okay. So we wrote it right up there. R is 2 minus 4m. All right. So I'm going to distribute the 1/2 through. What's 1/2 times 2? We get just 1. Minus, what's 1/2 times 4? 2. I'm going to multiply that out so I get some type of a polynomial. Four times 1. That, it's all multiplication. By multiplying one of them, it will end up multiplying the other. You could use the product rule right now. However, I'm fearful that we'll make a mistake. Let's just multiply it out. 4 times 1 is 4. 4 times negative 2m. Negative 2 over m times 1. And negative 2 over m times negative 2m. The m's will cancel because one's in the denominator, one's in the numerator. And negative 2 times negative 2 is positive 4. So now I have area in terms of what variable? M. So the area is a function of the slope. And it's equal to 4 plus 4 Yep, thank you. I'm just thinking ahead. We've got 8, and then we have a minus 8m, and then we have our minus 2 over. I need to take the derivative. What's the derivative of 8? 0. What's the derivative of negative 8m? What's the derivative of negative 2 over m? Very good, 2 over m squared, because it's negative 2m to the negative 1. And if you take that derivative, you get 2 over m squared. If we want to minimize it, we should take the derivative and set it equal to. How do I solve? Negative 8 plus 2 over m squared equals 0. Add the 8. So 2 over m squared is equal to 8 over 1. Cross multiply. 8m squared is equal to 2. M squared is 1/4. Therefore, m is it going to be positive slope or negative slope? I mean negative if you look at the graph. If it was positive, it would not form a triangle, would it? Right. And so that accounts for the other quadrant. If it was negative 4, 2, it would be a positive 1. So we created through our multiplication an extra solution. It's the negative 1/2 we're concerned about. So therefore, I have my point on my line, 4, 2. And I have my slope, negative 1/2. Write the equation for the line. Y minus 2 equals negative 1/2 times x minus 4. Negative 1/2 x. Negative 1/2 times negative 4 is 2. Add 2, I get point slope form and slope intercept form. That is the equation for the line that will cut off a triangle through 4, 2 that has the smallest possible area in the first quadrant. Isn't that impressive? I don't know, but the first year I taught this, I told the kids that they should be ready for a problem like this on the test, and there was almost a complete rebellion. And I trusted my gut, which said, put it on the test. And, you know, they were pretty angry. They were starting to lose faith in me. Just about every single person got it right. Once you guys practice this, I'll give you one for your homework assignment. Okay. I'm going to add to that. Those were the easy problems. I'm going to give you 3 difficult problems tomorrow. Love you tomorrow. Okay? Yes. Largest area. It would be an infinite area because you would be, you know, yeah, your slope would be negative, you know, yeah, basically negative infinity. That would be your slope. Be an infinite area. Okay. Goodbye, YouTube. Anybody want to give a shout out to Amber?
Sup, Amber Lab.
Sup, Amber Lab. Talk some math today. All right. Emerald does not want to say hi to you. She's done with you. She'll see you again 7th hour, apparently.